Good morning, everyone. I hope all of you are doing fine. Am I audible and visible to all of you? Can you see me? Please raise your hands and let me know that I am audible and visible. All right. Why is this not working? Okay. So, I think in the last class we had discussed friction and Newton laws of motion. I think is over. Uh, Let us start with a brand new topic today. And the name of the topic is work, power, and energy. Now, I think you must be knowing something about work, power, and energy. Any idea, anyone? What is work, power, and energy? So we'll be studying three terms over here under three different headings. First is work, then power, then energy, or may not be in the same sequence. We would be studying work first, then energy, and then power. Any idea what is work? Now, the way work is defined in your day-to-day life and the way work is defined in physics are somewhat different. There is a difference. There is a subtle difference between how work is defined in physics and how work is defined in daily life. For example, right now I'm teaching you, I'm doing some work, but if I talk in the language of physics, it may not be work. Someone carrying a load on his head and walking straight on ground, he obviously is doing a lot of work. But probably in physics, if you calculate the work done by this gentleman, that would come out to be zero. So the way we think about work in day-to-day life and the way work is calculated in physics are not exactly same. That doesn't mean that what we call work in day-to-day life is not work. It is work, definitely work. But to understand that work, it will need a much deeper understanding of how human body behaves. So we'll not get into that part. It is not a biology class. What we are trying to do here in this class is trying to understand what work means in physics. In physics, when you say somebody or something is doing work, what we actually mean by that thing. So if I ask you, what is work? What will you say? Work. You would have heard this term, I think, in 9th standard. What is work? Anyone? Online, offline, anyone? Would tell me what is work? I think you have a mic that you can talk. You can speak on this. Do you have that thing in your with you? Can anyone tell me what is work? When do we say work is done in physics? Not in real life, but in physics. Anyone would like to say anything? No one knows what is work? No, that is not possible. You should be knowing what is work. Anyone? Raise your hands who knows that what is work in simple definition in physics. I'm not looking for a complicated definition. Anyone with a simple definition? No one knows what is work? Are you able to hear me? Okay, you are able to hear me, but no one knows that is work. What is work? Surprising. Well, you should be knowing what is work. Anyways, if you said no, then that means it is no. That means you'll have to work harder. If you in 11th standard you don't know the meaning of meaning work, that means you'll have to work that much harder. That means 9th and 10th are already gone. Anyways, okay, not a problem. Let us try to understand the meaning of the word work. Now, whenever you apply a force on a body, now that force can do a lot of things. Karthik is saying, well done, Karthik, at least you are trying. I like students who try at least. You may not know it, that is a different thing. You may know it wrongly, that is a different thing. But if you don't try, that is the worst attitude that you can have, not trying. Work done by object using specific force. Karthik, you are not telling me the definition of force, beta. You are just trying to, I don't know. It's not a definition of work. What is the definition of work? The simplest definition of work that you can make is when you apply force on a body. Now, if you remember the definition of force, what is force? What is force? Force is a push or a pull. Now, this push or pull, what can this do? It can make a body to move. It can make a body to accelerate, or it can change the size and shape of the body. Force is a push or a pull. Remember, force. It can change either the size, shape, or the motion of the body. Now, here we are not talking about change in size and shape. Change in size and shape will come in a different chapter, which is known as elasticity. Now, that chapter I think is already covered. If it is not covered, we will cover it. That comes in elasticity where the shape of the objects are going to change. Here the shape is not going to change. Then what can force do? If I apply force on a body, if the shape is not changing, size is not changing, the only thing that can happen is that the body moves. Now you will say, no sir, I know an example where I apply force, size does not change, shape does not change, and the body does not move. For example, I apply a force on the wall right in front of my face. I apply a force, a large force I'm applying, but nothing is happening. No change in shape, no change in size, and it does not move. See, there is a change in shape and change in size, but it is on a very microscopic level that we are not able to see. So, whenever you apply force on a body, two things, one of those two things would happen. Either, number one, the size or the shape of the body changes. If it does not change, the body has to move. The body has to either accelerate or the body simply has to move. When is work said to be done? Now, when the size and shape of the body is changing, then also work is done. That work done will be dealt in a different chapter, that is elasticity. We are not doing the chapter now. But when the body moves, when the body gets displaced, then we say work is done. When the shape changes, then also work is done. We'll do it in a different chapter. So what is work done? Right now in this chapter, size and shape are not going to change. And hence, we'll not put that size and shape wala thing here. So what will we say? What is work? Work done by a force. When do we say work is done by a force? Whenever force is applied on a body, and the body moves, we say that work is done by the force. So whenever force applied on a body makes the body move, work is said to be done by the force, and that is how we define work done. Whenever force applied on a body, whenever force is applied on a body and it moves, it gets displaced. You can also write the term displaced, and it gets displaced, work is said to be done. Work is said to be done. Work is said to be done whenever you apply a force on a body and the body moves or gets displaced. That does not mean that when the size and shape changes, work is not done. Work is also done there. We'll do it in a different chapter. Now, that is the simplest possible definition of work that you can understand. Now, what type of quantity is work done? Remember, force is a vector quantity. When we're talking about the body getting displaced, the body getting moved, we are definitely talking about displacement. That is why I use the term displaced. So if I talk about displacement and force, these are two vector quantities. What about work done? What type of quantity is work done? You must be knowing this, right? What type of quantity is work done? Scalar or vector? How many for scalar? Please raise hands. You don't know what type of quantity is work done? Scalar or vector? Okay. Work done is a scalar quantity. If you don't know it, you now know it. Work is a scalar quantity. It really surprises me that you have not heard about work. It is really surprising. I am not able to comprehend that you don't know about work. And we have already done scalars and vectors. And you still don't know that work done is a scalar quantity. That means you are not at all not at all studying. If you are not at all studying, this is the right time that you wake up, because I must tell you that the NEET students are way ahead of you in terms of understanding and in terms of performance also, maybe, because I don't think that you guys are studying. It's a shameful act. I hope that you get up and start studying. Work done is a scalar quantity. Do we remember this? Can I have raised hand that we understand that work done is a scalar quantity? Okay, chalo. So far, so good. Work done is a scalar quantity. What are the units of work done? I will not ask whether you know it or not, because that will just disappoint me. The SI unit of work done is known as, it can be called as Newton into meter, Newton meter, or you can call it as joule. Work done is measured in joules. The SI unit is joules. You can also call it Newton meter. That is work done. Now, how do you calculate work done by a body? How do you calculate work done by a body? Now, let us draw a simple diagram. I hope you are making notes. Let us draw a diagram of a body of mass M. Now, I'm applying a force here, F. And let us say the body gets displaced. The body gets displaced from here to here. This is the displacement of the body. Let me call this displacement as dr. Dr, if you remember, dr is a very small displacement. Dr, I told you about two things. If I say delta r is a large change in position, large displacement. If I write it as dr, both are vectors, of course, then this is a small displacement, a very, very small displacement. Now, if I talk about work done, and if I understand that a force is applied on the body and the body gets displaced, very small quantity, there will be a very small work done, and this very small work done will be known as dw. Work done is denoted by the letter W. dW will mean a very small work done. So this dW is defined in this way. It is F vector dot with dr vector. This is the small amount of work done when the force F displaces the body by a small displacement dr. This is the small work done. So what is the total work done? To find out the total work done, what I'm going to do is integrate on both sides. So integral of dW will be equal to integral of f dot dr. We have done this in chapter number 1. I'm sure you know this. So I integrate both sides. If I integrate both sides, on the left hand side, I will get the work done. On the right hand side, there would be an integral. Now, whenever I am writing work done, I am always writing it as delta W. I don't know why. I'll tell you the reason. So delta W, the work done is F dot dr and both are vectors. Now remember, in most of the books that you see, work done is denoted as W. Work done is always denoted as W. In whatever books you see, it will always be W. But what I am doing here is adding any additional delta here. Now, why I'm adding this delta, I will explain later on. Right now, what I need to explain, I think, is this dot that I have put between F and dr. I have put a dot. Do you know what is this dot? Do you know what is this dot? What does this dot represent? Anyone knows? Please raise your hand. Yes, I see a girl on the right hand side. Can you just have the mic and tell me what do you mean by this dot? You raise your hands, right, beta? You are hardly in the camera, but I saw your hand. Yes, tell me, beta. What is this dot? Is that mic around somewhere or not? Okay, I have the mic in the on the front bench. What is this dot, beta? Tell me. Hello. Yes, your voice is very low. You just increase it. Your voice is very low.
Sir,
Yes, beta. Tell me.
it is a scalar quantity, sir.
Now, work done is a scalar quantity, but right now I'm talking about that dot. That dot. Do you understand what is
Scalar multiplication, sir.
scalar multiplication? Did we discuss in the class what is scalar multiplication? Did we discuss in the class before? What is scalar multiplication?
Dot product, sir.
Dot product. Okay. Next question. Did we discuss what is dot product in the class? Did we discuss it in the
Yes,
class?
sir.
Yes, we discussed it. So that is the dot product. Now, if you don't remember it, we'll just have a quick recap of what was the dot product. Dot product is also known as scalar product. Dot product, if you don't remember it, not a problem. You can just remember it now. Dot product is also known as scalar product. So how do I get the scalar product? If I have two vectors A and B, dot product is represented by the letter dot. A dot B, if I take the dot product of these two vectors, it is simply equal to the magnitude of A multiplied by the magnitude of B multiplied by cos theta. Now this entire quantity is a number, hence it is a scalar, and this product is known as the dot product. What is this cos theta here? What is this cos theta here? This cos theta happens to be the angle between A vector and B vector. Do we remember this? Can I have some raise hand that we understand this? We remember this. A vector and B vector, the angle is theta. Well done. Now this dot product can be positive. This dot product can be negative. This dot product can also be zero. What makes it positive? What makes it negative? I hope you remember this. Can anyone tell me when is the dot product positive? When is the dot product negative? And when is the dot product zero? Anyone who knows it? I hope you remember this. Who determines whether it is positive, negative, or zero? What determines whether it is positive, negative, or zero? Anyone? No one knows? The mic is getting passed on. Anyone? It's right now at the back. Okay, no one knows it probably. It is positive if the value of cos theta is positive. When is cos theta positive? When theta lies in first and fourth quadrant, or instead of calling it first and fourth quadrant, I will call it acute. When the angle between the vectors is acute, cos theta is positive and work done, or in this case dot product is positive. What about negative? Whenever cos theta is negative, the dot product becomes negative. Where is cos theta negative? It is negative in the second and the fourth quadrant. Instead of calling it second and the fourth quadrant, I will call when the angle between the two vectors is obtuse. Now, this is the last time that we are doing dot product. So if you don't remember it after this, well, you will not remember it ever in your life, because we might not be using dot product after this. This is the last chance to redeem yourself. And I'm not very happy with the way that you are studying, and I've made my displeasure very evident. Not happy with what you are doing. And I hope that you guys come up and raise your standards a bit. Otherwise, JEE Mains JEE Main will be going way ahead and you will be lagging way behind and not able to touch it even. Please wake up. This is still time that you can wake up. Else, there will be no time whatsoever. Please wake up, beta. When it is zero, when cos theta is zero, when is cos theta zero? When the angle is 90 degrees or 270 degrees. That means the two vectors are perpendicular to each other. Then this cos theta is zero. Now, if you still don't understand it, I will just draw a diagram here. Acute means one vector is like this and the other vector is like this, B vector here, or this B vector can also be here. So this is what I mean by acute angles. As you can see, it lies in the first quadrant or the fourth quadrant. If A is the x-axis, this one becomes the first quadrant and this one becomes the fourth quadrant. Theta, cos theta is positive, scalar product is positive. What I mean by obtuse? By obtuse, I mean if vector A is here, the vector B would be in the second quadrant, which is the green one, or in the third quadrant, which is the red one. So if I call this as A vector, if your B vector is like this, second quadrant, or your B vector is like this, third quadrant, then cos theta will be negative, and hence your dot product is going to be negative. By perpendicular, what I mean is very simple. We understand perpendicular. If vector A is like this, vector B is here, the upper wala one, or it's here, one is 90, one is 270, the dot product vanishes. It becomes 0. And I also told you this is how you can find out whether two vectors are perpendicular or not. Find out their dot product. Find out their dot product. If the dot product, if the dot product is 0, they are perpendicular. If the dot product is not 0, they are not perpendicular. Now, can I have some raise hand that we have understand this once and for all? Everyone, I hope you have gotten a very good. Please put your hands down now. I will give you one or two simple questions based on this so that this concept never escapes your head. And this is the first question. Now, instead of calling vector A and vector B, instead of calling it as vector A and vector B, okay, let me just call it vector because I have not defined force in the right way. Okay. Question number 1, vector A ka magnitude is 5 units. Vector B ka magnitude is 2 units. Angle between them is is 135 degrees. Find their dot product. Vector A is the magnitude is given 5 units. Vector B ka magnitude is given as 2 units, and the angle between them is given as 135 degrees. Can you find out the dot product of these two vectors? How will you find it out? Simply, you will just put the formula dot product A dot B will be equal to the magnitude of A multiplied by the magnitude of B multiplied by cos of the angle 135. You must know the value of cos of 135. If you don't know it, I will not be helping you now. Just put the values, get the answer, and tell me what is the answer here. What is the answer here? What is the answer for this question? No one knows the answer? So the magnitude of vector A is 5 units. I write 5 multiplied by magnitude of vector B is 2 multiplied by cos of 135 is minus 1 by root 2. So I put the values and my answer becomes minus 5 root 2. It is coming as negative. Why it is coming as negative? Because the angle is obtuse. That was it. Question number 1. I'll give you one more. My vector A is here, 2 units. My vector B is here. Vector B is 3 units. And this angle is given as 30 degrees. This angle is given as 30 degrees. You have to tell me, the value of A dot B in this case. To tell me the value of A dot B in this case. Simple physics. This is not a question of physics. This is a question of maths. You must be knowing basic trigonometry. Just have to apply basic trigonometry and you should be able to get me the answer for this one. Okay, how do I get the answer for this one? A dot B, I write the formula. A dot B is equal to magnitude of A multiplied by magnitude of B multiplied by cos of the angle. What is magnitude of A? As you can see, it is 2. 2 multiplied by, what is the magnitude of B? As you can see, it is 3 multiplied by cos of theta. You have to find the angle between them. What is the angle between them? The angle between them is this angle. Complete this angle. And how much is this angle? 90 plus 90, 180. 180 plus 30, it is 210 degrees. So it should be multiplied by cos of 210 degrees. Instead of writing it as 210, I will write it as 180 plus 30 degrees. It comes in the third quadrant. You must be able to know the value of this angle, and that would be the answer for this case. I will not tell you how to find the value of cos of 210. If you don't know this, go back to your maths class, the maths lecture that we had done, and I have already told you how to get the value. So you must be able to get the value of this one. This is how you find out the dot product of two vectors. Do you understand this? Can I have some raised hands? You understand this? Okay. If you don't understand the value of cos of 210 beta, you must go back and have a watch. The previous lecture on maths, we had already discussed this. It is simple trigonometry. Cos of 210, you should be able to find out. Now, if you remember cos product, and I don't know whether you remember it, you must be remembering that we had done some important point here. So I'll just write some important points about the dot product, because this is how we are revising it. Do you remember I? I dot I will be equal to J dot J will be equal to K dot K, and this will be equal to 1. I dot J is equal to J dot I is equal to I dot K is equal to K dot I is equal to K dot J. K, J and I. This is I, this is J, and this is K. All these are mutually perpendicular to each other. I hope you understand what I'm writing. J and K are perpendicular to each other. J and I are perpendicular to each other. I and K is perpendicular to each other. So in all these cases, their dot product will be 0. So if I dot a vector with itself, the angle between those two vectors will be 0. And cos of 0 is not 0. Cos of 0 is 1. So remember, I dot I is 1, J dot J is 1, K dot K is also 1, but I dot J or I dot K or J dot K in any combination is always equal to 0. If you know this now, which I'm sure that we have done it in the previous classes, still this is a recap. You should be able to find out the dot product of these two vectors. A vector is 2I minus 3J plus 4K. This is my first vector. B vector is I plus 2J minus 3K. The question is find A dot B. To find A dot B, in this case, your time starts now. A dot B. How will you find it? This is simple maths. 2I minus 3J plus 4K. We have to dot it, dot with I plus 2J minus 3K. I hope you remember this. So basically, you have to multiply these two. I dot I is 1, J dot J is 1, K dot K is 1, rest everything is 0. So if I dot these two, what will I get? Anyone with an answer? So this 2I will get dotted with I dot I is 1. So
Hello?
you will get 2. Yes, beta. Anyone was saying anything?
Sir, can you hear me?
Yes, beta, I can hear you.
Sir, 2I minus 6J minus 12K cap.
Beta, see, dot product is a scalar and you are giving me a vector. How can dot product give me a vector?
Sorry, sir.
Can it give me a vector? No, beta. So you have done a small mistake. What is that mistake? I dot I is
Minus
not
14, sir.
I dot I is 1.
It's
So
minus 14.
2I dot I, not a problem. You don't have to, sorry. Don't have to, everyone makes mistake. I have made a lot of mistakes in my life. Simple ones. The
Minus
most
16, sir.
Yes, that is the correct answer. Okay. How do I do it? 2I dot I dot I is 1, 2 is 2, so 2. Now, rest of everything with, if when I dot it with I, it will be 0, so I don't have to do it. So what next I will do? I'll use a different color pen. I'll just have to dot minus 3J with this. So J dot J is 1, minus 3 into 2 is minus 6. So this gives me minus 6. Now the third one, I don't have to do anything else. I just need to do K with K. K dot K is 1. 4 into minus 3 is minus 12. And you can just add these numbers and you will get your final answer. And your final answer, I think, would be 16. Minus 16 is your answer. Am I clear? Do we understand this? Can I have some raise hand that we understand this? Everyone at the back, girls, boys. Okay. Now, what can be another question that can be asked? Now, remember, we are not revising the entire dot product. We're only concerned with questions that can be asked. Dot product is a topic of maths. It's not a topic of physics. We're just doing things that we think that can come to us. For example, if I go to the previous question, this is the previous question, question number 1. Now, what I do is I add one more question here. I add a subsidiary question here. Question number A. Same question, find the angle between A and B. So same question, same data. You have to find the angle between vector A and vector B. Your time starts now. You have 2 minutes to do this, else I will do my part. How do I find the angle between A and B? Now, this is not a very difficult question. As I told you, any difficult question is made up of small questions which are very simple if you understand the basic concept. Now, what is the basic concept here? The concept is very simple. If I can write, what is the concept? Now, I will add this small thing in our class. what is the concept, so that it helps you in understanding the entire question. You don't have to solve the entire question. You can just remember what is the basic concept of solving this question. Now, what is the basic concept of solving this question? It is very simple. See, I know A dot B. A dot B is magnitude of A. I am just writing it as A. A means magnitude of A multiplied by magnitude of B multiplied by cos theta. This is the basic concept. From here, I can find the value of theta. For example, if I can just write it in a different way, I can write cos theta will be equal to A dot B divided by the magnitude of A multiplied by magnitude of B. This is the basic concept of this question, and it is pretty damn simple. Now I can just put the values. I can just put the value C, A dot B. A dot B. I've already calculated A dot B. A dot B is simply minus 16. A dot B is simply minus 16. That is already done. Divided by, I just need to calculate the magnitude of A, yellow. This is vector A, yellow. What is the magnitude of vector A? Any student can tell me this. It is very simple. What is the magnitude of A? Magnitude of A is root over 2 square plus 3 square plus 4 square. X, Y, and Z की value ली, and that is square का root. That is the magnitude of A. So 2 square is 4. 4 plus 9 plus 16. 9 plus 16 is 25. 25 plus 4 is 29. So this is simply equal to root over 29. So I write root over 29. That is the magnitude of vector A. Now I have to put it, I have to multiply the magnitude of vector B. It will not take rocket science for us to find out the magnitude of vector B. That is in red or pink, whatever color this is. I don't know the name of colors. See, simple things. You will see that what is the name of colors, but I can get confused between red, pink, violet, orange. I still don't know what is violet. Brown. Brown I know. Black. The only colors I know is brown, black, red, orange, yellow, green. Apart from that, all the colors are gone. Blue. I can't recognize colors. I don't know their names. What is the magnitude of vector B? To find the magnitude of vector B, you have to root it. I square, that is 1 square. 2j, that is means 2 square, minus 3k. So minus 3 ka square, minus 3 ka square is plus 3 ka square, doesn't make any difference. 1 square plus 2 square plus 3 square. 1 square is 1, 2 square is 4, 1 plus 4 is 5, 4 plus 9 is, I think, 13. So 5 plus 9 is 14. So 5, 4 plus 1, 5. So it will be equal to root over 14, and that is the answer for cos theta. So cos theta in this case becomes, if I write it here, cos theta becomes minus 16 upon root over 29 into root over 14. Do we understand this? Can I have some raised hands? If I know the value of cos theta, I can take the inverse and I can find the value of the theta. Well done. So this is how a brief recap of the dot product of two vectors, because we might be needing it. We might be needing it in this case, because work done is definitely a dot product. Work done is definitely a dot product. Please note this question down. Once we have noted this question down, we can come back to our definition of work. And I told you work done is the integral of f and dr. So now let us focus our attention, let us shift our attention from dot product, which was just a small supplement or a complement, onto the main thing. The main thing is work done. Now let us go back to work done and let us try to understand it in more detail. So the next heading is work done by a constant force. So instead of work done, I will write is delta W. I, I always write things in symbols so that the symbols become a part of your life and you get used to it. Work done delta W, and I have to tell you why I'm writing it as delta. So that I will tell you in the next class. Delta W means work done by a constant force. Now, when I say a constant force, this force must be same in magnitude and direction. So it must be constant in magnitude as well as direction. Now, can you give me examples of some constant forces that you can see in your day-to-day life? The simplest example that I can give you is the force of gravity. Gravitational force exerted by Earth on us, on everyone. We always take it vertically downwards. Actually, it is not vertically downwards. It is somewhere a bit more complicated. We'll do it in gravitation. But right now, for our purpose here, constant force could be gravity. Any force which is constant in magnitude, constant in direction. For example, if I go back to the previous question, vector A, if you look at vector A, if this vector A was a force vector, 2 is constant, 3 is constant, force is constant, this is a constant vector. If this was a force vector, this is the example of a constant force. Do we understand this? Can I have some reason that we understand this? Any vector, any force of this nature is a constant force. In our discussion, yes, I got you it up. In our discussion, gravitational force exerted by Earth on other bodies will be taken as a constant force. Look at force B. Look at the vector B. In vector B, I ka value, I mean the term with I is 1, the term with J is 2, the term with K sorry is -3. 1, 2 and -3, they're all constant. So this is also sorry, this is also an example of a constant force. This is the constant vector. This vector could have been a force vector. So we are talking about such vectors or such forces which are constant. They do not change in magnitude, nor do they change in direction. Such forces or such vectors are known as constant force. Now, what will be the work done by a constant force? It is very simple. Now, if I remember the actual formula, delta work done by a force was F dot dr. F dot dr. Now, it basically means it will be integral of F into dr into cos of theta. Now, I don't have to write the vector sign here because I have to multiply their magnitude. So it will be like this, F into dr into cos theta. Now, if F is a constant force, F can jump out of the integral, cos theta can jump out of the integral. It will only be an integral of dr. If I integrate dr, I will get delta r. So in that case, I can write work done as, I can remove the integral sign. I can write it as F dot dr. I have removed the integral sign and I have written F dot dr. This is only possible. This is only possible when it is a constant force. Do we understand this? Can I have some reason that we understand this? Work done only if it is a constant force. You can take the integral out. Integral is already there, but the value is known. That is why we have taken the integral out. F dot dr. This is the first way of writing it. Way number 1. Way number 2 could be like this. Delta W can be written as magnitude of F multiplied by magnitude of delta R, which is displacement, multiplied by cos of theta. So this is the second way of writing the same thing, whether I write it as number 1 or I write it as number 2. Number 1 also refers to a constant force, and number 2 also refers to a constant force. I'll give you example of both, and then we'll wind off today's class. Let us solve it with example. Let us take example number 1 on this. I hope you have written this. Okay. Let us take example number 1. A constant force Newton displaces a body by 2 meters the angle between them is 30 degrees. Find work done. Find work done. Can I have the answer for this one? So the answer would be simply force का magnitude is 5, displacement का magnitude is 2, multiplied by angle is 30, everything is a constant, so multiplied by cos of 30, cos of 30 is root 3 by 2, so your answer will be 5 into 2 multiplied by root 3 or by 2. This will be your answer. Do we understand this? Yes or no? Do you understand this? Yes or no? Great. Simple questions with simple answers. Now I make this question. Now instead of dictating this question, I am just writing this question. So now I have a force of 5 Newton, 45 degrees. And what I am going to do is I am going to displace this body by 4 meters. This body has been displaced by 4 meters. So initially the black one is the position of this body. Finally, the blue one is the position of this body. Force remains same. Angle also remains same. The body has been displaced by 4 meters. What you have to find out? You have to find the work done by number 1, 5 Newton force. Number 2, normal reaction. So I just write it as 5. Number 2, normal reaction. Number 3, the weight of the body. 3 forces I can see here. One is the 5 Newton wala force. One is the normal reaction from ground. The third one is the weight of the body. Now, instead of writing weight of the body, I can also write it as work done by gravity. So either you can take it as work done by weight, or you can take it as work done by gravity. Instead of writing gravity as gravity, I am writing gravity as G. So don't get confused. Just find out the work done by weight. Let us discuss this in the next class. What is the work done by the 5 Newton force? What is the work done by the normal reaction N? And what is the work done by the weight of the body? Anyone with an answer?
5 root 2, sir.
5 root 2. 5 root 2 is not the answer. How did you get 5 root 2? Yes, 5 root 2. Okay. 5 root 2 or 5 into something else. Okay, let me do it. I think you have done a mistake in calculation. Let us try to find out the answer for the first one. Work done by 5 Newton force. So work done, question number 1, by 5 Newton force. What is the work done by the 5 Newton force? It must be the magnitude of the force. What is the magnitude of force? It is 5 Newton. So far, so good. Multiplied by the displacement of the body. What is the displacement of the body? It is 4 meters. 5 multiplied by 4. Multiplied by the angle between force and displacement, the red one. What is the angle between force and displacement? It is 45. So multiplied by cos of 45. Cos of 45 is 1 by root 2. So your answer will be 5 into, remember, 4. On the numerator, we have 4. So we have root over 16. So it will be root over 8. So you must remember that 5 into 4 divided by root 2. 5 into 4 divided by root 2 is not 5 root 2. Are you getting my point, beta? Do you understand the mistake that you have made? Four will be 2 into 2. 1, 2, and root 2 can get cancelled. So that will be root 2. So your answer would be 10 times root 2 and not 5 times root 2. Do we understand this? Can I have some raise hand that we understand this? Great. Now let us find out the second one. The second one is the work done by normal reaction. Now look at normal reaction. Normal reaction is the green one going up. If I find the work done by normal reaction, work done by N, can anyone tell me what will be the answer? Work done by normal reaction. To find the work done by normal reaction, what we got to do? We have to find the value of normal reaction. How much will be the normal reaction? You have to find the weight of the body. The weight of the body is mg. Mg and normal reaction are equating each other. So the value of normal reaction will be mg. So I'll write it as mg multiplied by the displacement of the body is 4. Displacement of the body is 4, not a problem. Multiplied by the angle between N and displacement. See the angle between this N, which is perpendicular, and this 4. What is the angle between these two? The angle will be 90. Cos of 90 is 0, and hence the work done by normal reaction is 0. Do we understand this? Can I have some reason that we understand this? Great. Then comes the third part, and the third part is still simpler. I have to find out the work done by the weight. So let me now find the work done by weight. Question number 3. Work done by the weight mg. To find the work done by the weight mg, I have to multiply the weight, which is mg, no doubts, mg, multiplied by, oops, wrong color, multiplied by displacement, which is obviously 4 meters, 4 meters, multiplied by the angle between mg and displacement. Mg is vertically downwards. Displacement is horizontal, vertically downward, horizontal. What is the angle? The angle is 90. Cos of 90 is 0. And hence the work done by the weight mg is 0. Why it is 0? Third case. Angle between force and displacement is 90. In case of normal reaction, it is upwards. In case of weight, it is downwards. But in both cases, it is 90. Do we understand this? Yes or no? So remember, you can remember this as one basic fact. Whenever a body is kept on a surface, whenever a body is kept on a surface, the body will move along the surface. Normal reaction will always be perpendicular to the surface. Normal reaction would always be perpendicular to the surface, and hence work done by normal reaction in all the cases will be zero unless and until the body lifts from the surface. So even if when the body is lifting from the surface, normal reaction is already gone, so normal reaction becomes zero. That means work done by normal reaction by the surface in all the cases will be zero. Do we understand this? Can I have some raise hand that we understand this? So in today's class, what we have done? In today's class, we have seen what we have seen. We have seen the basic definition of work. What is work done in physics? It is a scalar quantity. SI unit is Newton meter or joules. Whenever you apply a force on the body and the body gets displaced, work is said to be done. How do we calculate this work done? Work done is the integral of work done, delta W is the integral of F dot dr. Then we saw what is dot product. Dot product is nothing but the scalar product. We have seen this. The scalar product A vector dot B vector is nothing but magnitude of A into magnitude of B into cos of theta. It can be positive, negative, or zero depending on acute, obtuse, or 90 degrees. Then we solved some problems based on these dot products, and we saw a very important concept that what I dot I, j dot j, k dot k is 1, I dot j or I dot k or j dot k is 0. We had solved some problems based on this. Then what did we see? We saw work done by a constant force. We can simply write it as F dot delta R. You can take the integral out, or you can write it as F into dr into cos theta. We have not seen. Then we saw the example of how do we find the work done by a constant force in some simple cases, and we have seen that work done by normal reaction by ground will be zero. We will begin the next class from here on. If you have any doubts, now you can ask me, else the class from my side is over. Take care, and we'll see you in the next class.